In this video, we'll discuss how to display data using a box and whisker plot, or also known as a box plot. A box plot is going to show what is known as the 5-number summary, and it summarizes the position of data using quartiles. We're going to be able to see a couple things from this, mainly the shape and again the position of where certain values are on the data set. So we're going to talk about this thing called the 5-number summary. And in the 5-number summary, here's what it shows. The 5-number summary consists of the minimum value, which is the smallest data value set. And in a box and whisker, it's called a box and whisker because you have this box right here, and you have these things called whiskers here. And the whiskers are going to show the minimum value and the maximum value. So here, this value is the minimum value. And this value out here will be the maximum value. So the 5-number summary consists of the min and the max. And then it consists of your quartiles. The starting point of the box starts at Q1 and it extends to Q3. Remember, we call the range from Q1 to Q3 is called the IQR. So it shows the IQR inside the box. And then this line within the box is going to be the median value. And those are the 5-number summary right there. Now, this is called a skeletal box plot. A skeletal box plot means that there are no outliers. In this class, we're going to draw modified box plots. A modified box plot displays outliers. And we're going to show outliers with dots. And here's what you need to know about an outlier. If you have a lower outlier, you're going to draw the whisker or draw the left whisker to the smallest value in the data set that is not an outlier. So here's what has to happen. If you have outliers present, then either the minimum or the maximum has to be an outlier because that is the smallest and the maximum value. Well, if the minimum is an outlier, you're going to draw the whisker to the next value that is not an outlier. And we show outliers by drawing dots in their places. So if you would see dots like this value now is an outlier. The same thing holds for a upper outlier, except that in a upper outlier, we're going to draw the right whisker to the largest value that is not an outlier. Now, let's take an example and see how we draw a box plot and incorporate outliers in it. So using this concussion data, the example we've been building on, we know that the minimum value is 18. We found Q1, that's 33. Found the median was 45. Q3 is 52 and the max is 91. We also know that the outlier here, there's an outlier at 91 because it was bigger than our upper fence. There are no low outliers, so here's what we're going to do. We're going to graph this function. We're going to graph this actual data. And when we graph this data, we'll start off by labeling the min value, which is 18. The next value would be Q1, which is at 33. The median, which occurs at 45. Q3, which occurs at 52. Then we have a max value way out here at 91. Now, the problem with 91, though, is we know that 91 is an outlier. And because 91 is an outlier, we need to draw our whisker. So we're going to start off here with our whisker. Start here at the whisker. The low side is the minimum. Starts there. Then it goes to Q1, opens the box. Q3 closes the box. And then you put a line in the middle to mark the median, or a line inside the box to mark the median. And then what would normally happen is we would draw the whisker all the way to the maximum value. But the problem with that is the maximum value is an outlier. So we need to go in our data set and find the next highest value, which in this case it happens to be 57. The next highest value that's not an outlier is 57. So we're going to draw this here, this whisker to 57, because that's the next highest value, is not an outlier. And we'll mark the outlier 91 with a dot. Now, from this graph, here's what we're going to be able to see. We can see the 5 numbers somewhere, and occurring within each one is a quartile. So that means that from the minimum to Q1 is 25% of the data. From here to here, is also another 25% of the data. Then from here to here, it's also another 25%. And then now from here all the way till out here is the additional 25%. So what you understand is that there's 25%, or these quartiles, your box plot is showing your quartiles for each interval that's marked on this box plot. And what we can do is we can show the shape of the distribution. And remember, we have 3 shapes. And the shape for a box plot looks like this. Your 3 shapes are, it can be left skewed, symmetric, or right skewed. When you talk about a left skewed distribution for a box plot, what that means is that the whisker on the left will be longer than the whisker on the right. And when you talk about a right skewed distribution, the whisker on the right will be longer than the whisker on the left. And when you talk about a symmetric distribution, your whiskers will be about the same on both sides. So notice that, again, it's just like a curve. Wherever the tail is longer at, or in this case, wherever the whisker is longer at, that's the shape. And what can we tell about these shapes? Well, we know that in the left skewed here, even though this box plot doesn't show means, box plots never show means, they only show medians. But because the shape of the distribution is left skewed, I know that the mean has to be less than the median here. Here the mean has to be greater than the median. And here the mean has to be, the mean for here has to be equal to the median. And the mean here is greater than the median, just because of the shape of it. Another way we can look at box plots, especially those that include outliers, is now, no matter the shape of this box plot here, so no matter the tail length of the box plot or the shape length of the box plot, if you see outliers present, such as something like this, this will be skewed in the direction of the outlier. So this is also a left skewed distribution. If you see outliers present on the right side, such as our graph above, it will always be skewed on the right-hand side. It will always be skewed on the side of the outlier. So up here, this particular graph is right skewed because of this outlier value. If the outlier were removed and we just looked at the box plot itself, well, the box plot is pretty much symmetric here. But with this outlier, it's making it right skewed, which means here, this 91-day value right here is pulling the mean in this direction, and it's making it seem really huge. If you remove this value, the mean and median would be fairly close to each other. So keep that in mind. Box plots show shape. They show position. Position being these quartiles. So Q1, the median, Q3. And They also show where 25% of the data lies inside of each one of these intervals, and that inside of here, this box again is called the IQR. And when we start to talk about shape now, just like with measures of central tendency, when you talk about a box, when you talk about a box plot, you talk about measures of position. Remember with central tendency, we talked about resistant and non-resistant measures. A resistant measure was not affected by change. And remember, the resistant measure for central tendency is the median, because the median doesn't care if you have extreme values or not. It wants to sit in the middle. Well, here for positional measures, the resistant measure, is going to be the IQR, or any one of the quartiles, Q1, Q3, and again, the median. They don't care about extreme values because they want to sit in certain positions. The non-resistant measure, and remember, the non-resistant measure for central tendency, the middle measure, was going to be the mean. And we use that when we have a symmetric distribution. Well, the non-resistant measure for this, or the value that includes, remember, the mean takes into account every value. That's why we use it for symmetric distributions. But when a distribution is symmetric, here we want to talk about its measure of variation or position. We're going to talk about the standard deviation, because the standard deviation takes into account all the values. So keep that in mind again. The resistant measures are IQR, Q1, Q3, median. We talk about the median for central tendency. We talk about the other three. We talk about these three for measures of variation. The non-resistant measures are the standard deviation for variation. When you want to talk about variation, you have symmetric distribution. You talk about the standard deviation. And when you have a symmetric distribution for the central tendency, you want to talk about the mean.